closer to him so we're not spread out. That's good right here.
T24, M06. End of block, right, cycle start. The block. Well, let's go to back up to manual. Cancel. Cancel. Go over to pocket milling. Hit right. Okay, go to the rectangle. Okay, both these routines, you can see the zero location is going to be on the center of the block. We're going to set the center of the block as a 0 point. And the block is 4 inches wide and 4 inches long. So let's go back out again and get into the setup mode for the part. Right, down to the work, right. Let's go into F2. Okay, we'll go on over. Back up. Back up. Probe what it says near the approximate center and just above the Z-axis surface and press cycle start. So let's go on over. It'll work and jog right there. You can jog the tool over and down. Bring it into about ½ inch above the top of the part. Casey, you want to get him a scale, flexible scale in that drawer over there. Okay. David, you want to take a look on the side and see if he's close to the center of the y-axis? How's it look y-axis? Okay, cool. About ½ inch above it? All right. Take a look at your length now. It's talking about the X length. And the X length they're talking about is 4 inches wide. It's 5 inches. I don't like it. Go ahead and do it again, but this time come on down to 0.7 inches instead of 0.6. Just go down and you're going to have that length again, yeah, and the width. Make it 0.7. 00 cycle start. Do it again. Look at your X and Y offsets. See if they change. I don't really think they will, but it could. I want to make sure we got the ball, the actual center of the ball on the edge of the part. 6. And I've already set that tool length before. I've already used it, so I know it's okay. Let's go back into setup mode and go straight over to pocket milling. What would you like to mill? Radius, rectangle, square, what you fancy?
Rectangle.
Rectangle. All right, we've got a rectangle set up. Hit right. We're not going to center drill it, so that's going to stay 0. Work offset's 50. End mill is going to be tool 3. Okay, it's going to be the same offset, so come on down for that. Come on down to the X starting point. It's going to be 0. Y starting point is 0. Our plane is 0.200. Remember, the R plane is just above the top of the part. It's going to rapid traverse.
It'll actually be 102, won't it? Or no,
now leave it at 0.2. That's fine. And the depth of the pocket, I'm already 100 thousandths deep. Let's go make it 150. 0.15. All right, incremental depth, 0.150. Take it in one pass. Distance in X. How big the pocket do you want? How wide? 3 inches. How about width?
2.
2 inch wide. Okay, we got everything answered. It should come down the center of the block and machine a 2 inch wide, 3 inch long rectangle. Okay, go ahead. Get ready with the feed hole just in case. Remember, we've already told the machine what kind of material we're running. We're running aluminum, 6061 aluminum, so it's already picked out a surface footage to run for speed, and the feed rate it picked it out also because we told it's a 3/8 diameter end mill, 2 flute, and it knows how fast to run, and it's got a pretty good feed rate on it. Casey, let's go over and draw. Let's cut a 2-inch diameter circle in the middle of that pocket. So it cancel, back out of it a little bit to cancel on the bottom. Okay, and go back over to just past center drill, so we know hole depth. Our work 0 offsets is G54, X starting point is 0, Y starting point is 0. Tool number 3 for the end mill. Our plane at 200 thousandths above the top of the part, 2-inch diameter pocket. Total depth of 200 thousandths, which would be 50 thousandths deeper than the... Pretty cool. Blow it off a little bit. Okay. Let's put a square right in the middle of that. That's machine. David, come over and let's do an 1.5 inch diameter square. Okay. Center drill is going to be 0. And tool 3 is right. G54 is correct. X starting point, or the depth of pocket, let's go back up there. We've got the hole, we went 200 thousandths, let's make it 250. Okay, incremental depth, 0.250. We're gonna make it 1 pass. Okay, distance in X, let's make it 1.5. Same thing in Y. And our R plane is 200 thousandths, that's cool, that's not gonna change. So everything should be fine. We've got no center drill. Work offset of G54. Starting point is X0. Y0 for the Y point. Our plane is 0.200 thousandths. Tool number 3. Depth of pockets 250 thousandths or 50 thousandths deeper than the rectangular, the circular one we just did. Incremental depth 250. We're going to do it all in 1 pass. 1.5 inch by 1.5 inch square. Cycle start. Pretty cool, isn't it? So we've done all 3. We've done a rectangular, a square, and a circle so far. Let's go ahead and drill some holes. Dan, you're up again. Come on over, Kent. And the drilling, and we've got a choice of bolt circle, bolt line, or single hole. Let's do the bolt circle. Okay. Center drill, let's go tool 1 is our center drill. Center drill depth, hang on a second, let's 0.150. Okay, center peck 0.150, same depth. We're still going to use tool 2 for the drill. Drill depth is 0.5. Drill peck 0.5, do it 1 pass. And tap is 0, so there'd be no tap depth. All right, we got the G54 with 0 offset, X center point is 0, Y center point is 0, R plane's 0.2. Diameter, let's do a 3.5 inch diameter bolt circle. Number of holes, how many holes do we want to do?
5.
5, okay, 5. And do we want, because the center hole is so much deeper. Okay? Close the doors. Cycle start. Bingo. So the tool probe on this thing, go to tool number 2 again. So let's go to back to the setup here. Go to the tool. We've got tool 2. Go to F2. Tool 2. Approximate length is 6.5. And approximate diameter is 5/16, which is 3.
Oh, 3125.
That's right, 3125. And the Z distance coming down about 300 thousandths, 0.3. Okay, let's close the doors. And cycle start. And it'll automatically set the tool length. Right? Yeah. Cycle start, see what happens. Okay. Okay. When you close, you can slow it down, use that hand wheel. Get closer. Help him out, Dan, with the Y-axis and let him know when he's close to the corner. The center of the probe should be right on the middle of that corner. Yeah, it's slowed down. Get it to about a ½ inch. Dave, would you go over and get him a flexible scale on the drawer over there? Say a ½ inch, doesn't have to be exact. It's pretty close.
Center of the ball or bottom of the ball?
Bottom of the ball. Okay. Then you want to be right on the corner. Is he pretty close to the Y, Dan? You can bend that scale here. See, you can get in there and right on the center of the ball is on the very corner. I want the center of the ball right on the very corner.
How's that look, Dan?
Okay. Let's close the doors. And go back to hand jog twice. We got to go back to where we were. We still got corner 4 and 0. Okay. It should be cycle start. And it should reset our 0 location right at that back left-hand corner of the part. Okay, jog it back up in Z. Speed it up a little bit more. That's slow as you go, yeah. Z up. Okay. Now leave tool 24 right in there. Let's go back to our face routine. taking 100 off the top of that part. That had the OSU that we ran the Cincinnati on it. So I've already faced that off. That's what it did.
Didn't clear all of it off.
Well, that knocked a burr, I believe, over the back side of it. So that's all right. That'll work. Let's go ahead and call up that tool probe again. In the MDI, you have to go back to programs. And go to programs first. Let's go back to setup, hit right. And we want to do the work this time. Scroll over to work, right. Hit F2, because we want to use the probe. And scroll through it, go the other way. Bingo. Okay, we want to go ahead. Let's go back to and do the top of the part first. Let's go back and get our Z0 again. Go over to the end of it. Let's go back over to here first. Okay, and let's jog it and get it ready down someplace flat on the top of that part. Jog it over. And we want to position the probe near the surface. You want to measure and press cycle start. The distance and direction has got to be a negative value when it up in here. These are going to be 0 locations here, the X and Y are going to be 0, but first you can jog it over. We want to jog it somewhere like right here where it's nice and flat and bring the tool probe down to within about a ½ inch of that surface right there.
Does that have to be hand job?
Yeah. Casey, let you do this one. I'm going to work Ken out here. I'm going to bring that over and jog it down within about a ½ inch of the top of the part. Roughly a ½ inch, that's fine. Okay, so go back to hand jog. There you go. You want to go to F2. And it's right there. The X distance we're going to move is going to be 0. Y distance is 0. The Z value, now if you look down there, it's talking about distance and direction, plus or minus. So we're a ½ inch above the part, you want to say minus 0.5. Because you want the tool to go in the minus direction a ½ inch to contact the top of the part. It'll offset, take a look at your Z offset value, and that should change as soon as it hits top of the part. Okay? So now let's bring a tool, leave it at the same depth, but just bring it over in the X and Y to the center of that block. Okay, go back to cancel that, go back to work, hit right there, and off 2. That's right, now back up towards where we were before. Yeah, hit F2 again. And just jog it back over that one there. The X length, that block is 4 inches wide and 4 inches long. Incremental value. Now there it's not talking about a plus or minus, this just wants to know the value. We're a ½ inch in front of the part, we can come down 700 thousandths. Okay, and the X adjust is 0 and the Y adjust is 0. Close the doors, cycle start, and come in there and probe both sides of that part. Cool. Jog it up in the air. All right. David, your turn. Let's go ahead and go back to the intuitive programming. And let's machine a circular pocket in this thing. This pocket milling, right? Do a circle, right? Okay, no center drill. No, so it'd be no hole depth. And end mills 3, that was cool. G54, yep. And our plane is 200 thousandths. X starting point, or the diameter of the pocket. What diameter of the pocket? Let's do a 3½ inch diameter pocket. Let's do a big one. And the depth, make it 0.1, make it 50 thousandths. And passes 1, 0, 0. Everything should be cool. Close the doors.
Is that the same diameter as
Is the bolt circle, yeah, will be. Cycle start. Cool. Go ahead and blow it off a little bit. Just blow the top of the part off. Daniel. 2.0. There you go. 2.0. Cycle start. Awesome. Go ahead and blow it off lightly away from Rex, right the other way. Yeah. That's good. Looks good. Looks like Swiss cheese.
Thank you for wearing orange today.
Oh, you're welcome.
Tell me your name.
My name's Daniel Brush.
Okay, and can you spell first and last name?
Danielbrush.
Okay, just like it sounds.
Yep.
Okay, Daniel, what got you attracted to this program?
Oh, I don't know. I didn't really know what I wanted to do after high school, and this was about the most appealing to me. So I like working with my hands and stuff, so I got into this. And it appealed to you, but now you've had a chance to experience what you found out. It's pretty much what I expected. I like doing it, all of it. I like programming the machines and all that stuff, and making parts and just working with my hands.
Have you got any kind of idea how this is going to lead to a career for you?
Yeah, I got a pretty good idea. Just probably get a job somewhere running a machine for a little while, and then hopefully move up and possibly program machines one day or something.
So when you thought about getting into manufacturing, was this kind of environment what you envisioned manufacturing to be like, or is it somehow different?
It's a lot cleaner here than all the other stuff I've been around. The other machine shops I've been in have all been just little ones at people's houses and stuff, and this one's a lot nicer.
What do you think it's going to be like when you get out in the real world?
It's probably going to be different, but a lot of it's still the same. I don't know.
How long have you been going to school here?
I'll actually graduate in the summer, in August, so I'm almost done.
Have you done an internship or anything?
No, I haven't.
Are you going to get?
No, I don't think I'm going to.
Okay. Have you visited any industrial sites?
We went on a few tours and stuff in some of our classes and seen machine shops and glass plants and stuff.
What'd you think?
I liked them all. I don't know. I just like the idea of running a machine mostly.
Good. All right. Okay, just tell me your name.
My name's Casey White.
And how to spell first and last name.
CASEYWHITE.
Okay. And so Casey, been on internship. That's way cool. I've heard it's a really neat place.
Yeah, it's pretty neat. They make all different kinds of bottles. And I work down in the mold shop where they repair the molds for the glass. I didn't think it was all that much, but there's a lot of work that goes into doing that. There's all different kinds of things. They got a few CNCs you can run, and mostly manual stuff and handwork. So I really like that a lot.
What kind of relationship do you see between your internship at a real manufacturing plant and what you're doing here?
It's the basics are the same. This is more modernized, and that's you're more working with your hands, but it's the same thing pretty much as far as the CNCs, codes, and everything. It's all the same.
So do you feel like you're going to be, how well prepared do you think you're going to be when you come out of here?
Well, I got there and I know pretty much how to do most of it just because I went to school and I know how to do it. So.
And what got you interested in coming to OSU?
I went to Votech my last 2 years of high school, and I like working with my hands, and it just felt like come natural to me. So I took that, and then I wanted to further that, so I wanted to come here.
And so when you say working with your hands, it's not just your hands though, like there's also the mental thing, those
Yeah.
you study things. What's that whole process that really builds you into somebody who's going to be successful?
Well, I don't know, I'm real mechanically minded, and I don't know, it just comes easy for me to do it. Some people, everybody has their own thing, but I just like this.
And how have the teachers been here? How's it been to actually work with the teachers? Do they give you any time?
Oh, yeah. Yeah, they help you, whatever they need, and they show you how to do everything, and real helpful. You go to them for your classwork or the machine shop, just one-on-one, lots of one-on-one help. That's really helpful.
And also I'm kind of wondering about, you also have to take like arts and science classes, things like that. Do you feel like that's going to help you in any way in the future?
Some. It kind of depends on what you're going to do after you get out of school, where you're going to work. But I can see where it helps a little bit.
Why do you think it would help you?
Well, I don't really know. I don't really know.
Might be management type stuff or something.
Yeah.
What about like looking down the road for your future? What do you see yourself doing?
I'm probably working at that glass plant. They've given me a real good offer, and I'll graduate this December. That's probably where I'll end up being because it's stuff I like to do down there.
So when you're down there and you're working and doing all that stuff, you like the people, you like the
Yep.
assignments and all that?
Yep. It's a real nice bunch of people down there.
All right. Okay. I'll wait for that red light. Okay, tell me your name and how to spell it.
Kent Morrow, Kent Morrow.
Where are you from?
I'm from Schulter.
Schulter.
Yeah.
Schulter. It's not too. Where is that?
It's about 10 miles south of here.
Oh, okay. All right.
It's itty bitty town off the side of the highway.
So, did you go to school in Schulter?
Yeah, I graduated high school there.
So, what made you want to make the leap from that little bitty town on the side of the highway to college?
Well, I knew there wasn't much around there for me to do, and in school I didn't really know what I wanted to do. And Green Country came and toured, and they were trying to interest some of the students in coming, and so I decided to go into manufacturing there. And then I changed my mind and decided to do drafting. And after Votech, I just decided I'd go ahead and continue that because it seemed like a lot of fun. And I always liked working with my hands and designing and fabricating.
So, are you in the design drafting program or the manufacturing?
No, I graduated in design drafting in last April, and then I continued in manufacturing this year, and I'll be graduating this April in manufacturing.
So, are you going to have 2 degrees then?
Yeah, I'll have two associate's degrees.
Wow, you're a pretty ambitious guy.
Try to be.
So, what do you think 2 degrees are going to position you to do with your life?
I think it's going to open up a lot of doors for me to have a lot of opportunities to do a lot of different jobs.
And would you recommend this? Why would you recommend this college to other people?
Well, here you get a lot of one-on-one with the instructors. Your classes aren't very big. If you have any problems, you can always go to them. Any classes, it doesn't matter what it is. Or if you need help with family matters or something, just someone to talk to, they're always there for you.
not really what I would think of as a college being that helpful on all levels, but you found it to be like that.
Yeah.
And have you had any job offers, any opportunity to kind of see what the career potential is going to be like for?
Well, I've gone on a couple of tours, and I've looked around here in Okmulgee and Broken Arrow, and it seems like it'd be a lot of fun to be able to work for a machine shop.
And have you had any offers yet?
Not quite. I was trying to finish out my degree, and then the closer I get to graduating, I start looking and see what I can find.
Cool. All right. Okay, and just tell me your name.
David Safari.
Okay. And can you spell, I guess David's D-A-V-I-D.
Yeah.
How do you spell your last name?
Saffari.
Okay. Where are you from, David?
Here, I'm from Tulsa, but I'm staying here in Okmulgee.
Okay. You living on campus?
No, I got a house right outside of campus.
Okay, cool. So how long have you been going to school here?
For about 2 years.
How many years?
2.
2 years.
Yes.
So you about ready to graduate?
Yeah, I'll be graduating in August.
So what would you tell someone about your experience here?
So it was great. I was in the civil engineering program, and that's a 4-year bachelor program, and I wanted to do something quicker because I got a family and stuff, and this seemed to interest me, and the pay is good, and so I decided to go with this.
And tell me a little bit about your experience in the program, like the teachers, what you've worked on. Do you feel like all that's helping you get prepared for it to be successful?
Yeah, the teachers are great. Like, they're really helpful. If you ever have any problems in the class, you can just ask them about it, and they're always more than willing to instruct you and help you out and stuff. It's a great experience, really.
What are some of the things that you look back and think, man, I really like that?
Just the instructors, really. I mean, they made the program really fun and you know, a joy to come to school, and not always having to be like, oh, I gotta go to class. You know, you look forward to going, and it's fun to go.
And do you feel like the kind of equipment, supplies, all that kind of stuff is going to help you stay up to date, or are you going to have a big learning curve when you go to work for a big company?
No, well, when we go on tours and stuff, when they hear what school we're from, they're always more than happy to offer us jobs or applications and interviews and stuff. Like, every time we go on tour, it happens. It's pretty nice.
Cool. Ken, this seems like maybe the perfect hands-on class to be taking.
It is. It really is. I'm really proud of this program. We can take students that have had absolutely no experience whatsoever in machine shop, or ones that have come through career techs programs, or ones that have family members' own shops. So no matter what their experience is, we can teach them anything they need to know to really, be successful in manufacturing. We teach them everything they need to know from conventional machining, and it's all project driven. So that we teach them how to run the machines, the speeds, feeds, tooling, and exactly how to do it, and then actually make them do it. And the proof's in the pudding is what we make it come out. So that's the name of the game.
You've probably been doing it long enough now that you've gotten some feedback from people in the industry about how well prepared these students are. What do you hear?
Absolutely are. When we have our advisory board meetings, we talk to them, and I visit them as well. A lot of the people in the industry still, and keep in contact with them. And over the last 40 years, I've got a lot of contacts in the industry, and I know what they want us to teach. And we've got students now out there. I've been doing this almost 3 years now, so that we've got some really good positive feedback. I went over and visited a student that was in internship a couple weeks ago, and they were real pleased with his knowledge and the way he was able to just walk in and start working without a whole lot of training. And that's the name of the game. They should be ready for industry when they leave this program, and that's the way it should be.
This is kind of the time of the stimulus package and the recession. How is it going to bottom out? People talking about recession-proof jobs. How do these jobs do in economics?
They really stack up really well. This is a real skilled trade, and manufacturing is something that's never going to go away in the United States. There's always going to have manufacturers. As a matter of fact, we've heard that a lot of the jobs are moving back from China and Mexico back in the United States, which is a beautiful thing. And there are always going to be jobs for these students, always.
The equipment that you have here is really impressive. What's the story behind that?
I'm really proud of it. OSU has really stepped up and bought new equipment and kept up with what's in the industry. These machines here, like this one behind me, is state of the art. It's brand new. It's about 6 months old. This office mill, it's over to my left, is the first one in Oklahoma, as a matter of fact, of its kind. So we have a real variety of different machines, from old ones, because there's still a million old machines out there. So we make them learn those, as well as this new technology as well. So we try and run the whole gamut. So when they do get out in industry, they can always fit right in with very little training and get and run.
Okay.
Okay, how we doing, guys? That's not where it goes, so we spin it. And there it is, okay? And then find it, okay? Okay, whichever axis you decide to work on first, you get it as close as you can in either the X or the Y first, okay? Right, do only one axis at a time, okay?
All right.
Yeah. So.
Zero.
Zero now.
We were 3, negative 3.
Positive 3, negative 3. And 0 right here.
Negative 3.
No, negative 4 this time.
Alright. Got it what? Oh, no. This is our low, this is our high.
Okay. So. Turn head. This, you said this is low, right?
This is low.
Okay.
So,
It needs,
yes.
yeah, it needs to come towards
Towards us.
the high side, so we need to put down here,
Bring it up.
or that, or there.
Back. Negative 3 here. Positive 3 up here.
That's pretty good then. So just split the difference. So you're going front to back, right? And you're going to split the difference. You have 6 total. 6 total. You're going to give it 3 here, which will bring it.
let me know when it gets to 0 off.
Alright.
There's no pressure to get it absolutely right just because the camera's on you, Irvin.
It's a 0.
Alright.
So how are we now?
Brought it up to a 0, and now we're positive 12 up here.
Now don't be afraid to unlock it and just tap it with the mouth. Watch it, okay? Bring it back in. This right here, this is a real fast adjustment. If you want to slow it down, you use the mouth to make sure you're using flat surfaces. You don't want to hit any of the knobs or fasteners. Right. See, we need to lock this down right here. Don't fall, Rex. No, you might need that. Okay, so. Right. Good. Now you understand. As long as you understand which direction you're going, you should be able to figure it out. Are the lights making you nervous?
No, it's right there.
Right here? It's jumping in this direction and just going out back down. So close. Where to go to? Two. Four. Whoa. Go back a little bit.
little more. Okay.
20 minutes, guys, 20 minutes.
I guess I need a tripod.
name's Nicholas Kelsey,
Can you spell your first and last name?
Nicklauskeelsey.
All right. Where are you from, Nicholas?
Manford, Oklahoma. We went, well, yeah.
Cool. Manford's kind of a neat place to live, isn't it?
Yeah, we're right by the lake and everything. Got wakeboard competitions and stuff like that.
So what do you do during the summer?
We go out on our boats. We have a couple boats. We have a Mastercraft and we go wakeboarding on that a lot.
Wow, too cool.
Yeah.
Well, what made you want to come to OSU Institute of Technology?
Well, I heard they had the best machining program around. So that's what and my cousin, my dad and my brother, they both went here and graduated from here. So
That kind of motivated you to do
yeah,
the same thing?
I kind of wanted to come here anyways. So
Why did you decide you wanted to get into machining?
well, my cousin, he was into machining his whole life, and he had a bad motorcycle accident, and he passed away it was 2002, I believe. And it just, I don't know, I've always wanted to be a machinist. You can make anything out of metal. Just be able to, the lathe is one of the only machines that can replicate itself. So it's pretty neat.
Yeah, I hadn't thought about that. The lathe is the only machine that can replicate itself.
Yeah.
So was there anything in your childhood or high school or grade school that made you think, hey, I could be a machinist?
Well, it's just, I was wanting to be a welder for a while, but then I didn't know about machining, all the stuff and CNC and stuff. And it's just, it intrigued me more. And I was just like, man, I could do that and make anything, and it's better, you get out into a better field and not be breathing all those fumes and stuff.
Sounds like a good deal. What were your expectations of this school when you came here, and how closely has it met your?
Not what it is. It's more than I expected. I mean, they have more machines and just everything. There's lots of stuff out here. I mean, it's just millions of dollars worth of equipment. It's nice. I love it.
And how well does that prepare you for your future in business?
Well, I'm wanting to go into the Corps of Engineers and be down there, and I won't be doing too much CNC work, but on the manual mills and manual lathes, I'll just be making parts, and it's gonna prepare me very well.
Have you had a chance to go tour any industry?
Yes, we have. We went to Halliburton, and they have some of the biggest machines I've ever seen. They're huge, just big.
And so that would be kind of intimidating. Do you think you're getting the kind of background here that you could walk into a place like Halliburton and?
Oh yes. They're all the same machines, except it's just bigger. It's a larger scale.
What do you see your future being in as a machinist?
Oh, I want to be a manual machinist, fixing parts on CNC. There's parts out there that are worth $5,000, and if I can save that part, like saving a thread or something, then I could save that part, and that's what I want to be. I want to do my own thing on the stuff.
Have you had any indication from any companies that they'd be interested in?
Yes, I have. The Corps of Engineers is very interested, and cause I've been going back to them though, because I really want to get there, because it's working on the lake or where I like to be, and so staying out there and having fun.